Okay.
Hello, everyone. Very nice to see this many faces here, so thank you all for coming. The next half an hour we will spend together talking about this topic, how AI-driven automotive connectivity can support uptime and reliability when it comes to software-defined cars. So it will be very much about how we use data to make sure that connectivity is not only a best effort item anymore, it's really about securing that things work. Because as we know, nowadays with the software-defined vehicles, all the full user experience and the promise around the car relies on connectivity. And my name is Högberg. I work for Telenor IoT, where I head up the automotive ambition of this company. And I have been working with cars and connectivity through my whole life, both in Sweden and here in Germany. And I've been on the telco side and on the OEM side. So I have a view on the challenges and opportunities that comes from for all of us. And with me on stage, I have the pleasure to have my colleague Anders.
Okay, nice to meet you all. My name is Anders. I'm head of data at Telenor IoT, and to put it short, I just love data, okay? So I'll come back to that later.
Yes, and so you are the star today, and I will just more or less do the moderation, because this is a presentation about AI and data, and not so much about our company. But I think when you do a presentation like this, it's suitable to say a couple of words about who we represent. So we work for Telenor IoT, which is the dedicated IoT company within the Telenor Group. Telenor Group as such is a Norwegian global operator, but we are based with our head office in Sweden. And we have been around in this business for 20 years, and by now we connect around 25 million cars and other type of IoT products, and been on a steady growth journey since then. So a nice business to be in, I would say. We are present all around the globe, as you can see here, and we are very glad to be trusted by some of the world leaders when it comes to cars, for example. And you see a few of those brands here, but for example, currently we support 8 out of the 10 largest Chinese car OEMs with overseas connectivity in some part of the world. And at the event here at IAA, we are also very happy to introduce you to our new offer, which is called IoT Drive. And it's a tailored connectivity offer to the automotive and primarily the passenger car industry, because we know that automotive IoT is different than if I use the word general IoT. So with this offer, we combine what we think is most important to serve passenger car companies all around the world. The offer as such consists of a managed connectivity part, which is about securing access to networks and management solutions, technologies and standards all across the globe. I will not go into this, but I think you know what I'm talking about if you are in IoT and connectivity. The second part of the offer is a new product that we bring to the market now called Consumer Connect, which is our in-car connectivity platform, which is very much about finding new revenue streams and support the whole in-vehicle experience. And for this, other platforms, tools, and compliance is needed to support customers on this journey. But now, enough said about this. We also put a lot of pride in how we work with data and AI, which is the third cornerstone of this offer. And as I started off when I did the very high-level introduction, we believe that this is really key, because we cannot compromise on uptime and reliability when it comes to the life cycle of the car. And it's both about the car OEMs, but primarily about their end users, that at the end just would like to enjoy their cars, and they should never even consider that we exist. because we do our job so well that they never notice us. So with all of this, I will not bore you with any more product talking, and instead, let's deep dive into the topic of today, which is our AI and data engine, and how we can share and discuss best practice when it comes to how we use AI to monitor all the cars and other devices out there in the world and proactively resolve issues. But because unfortunately, we know they still happen. And then we will also go into maybe a little bit of another buzzword, but we will talk about orchestration and how we can use data to do that maybe in a new way. Because as I said, the software-defined car is quite a, as we all know, it's quite a complex thing. It's about hardware and software and connectivity working together to create a greater experience that we have seen in cars before. And connectivity is really the enabling technology. It's not about connectivity in a way. We're just there to make another use case at the end come to life. And believe it or not, although we have been in this industry for 20 years, as I said, we still hear a lot from our customers that connectivity is like a black box. We don't understand what is happening out there, and there are problems and issues, and no one can really tell us what it was or what happened. And for us, it shouldn't be like that. Connectivity shouldn't be a black box. Data is something we should be very transparent with, so we can help our customers and, at the end, the whole society and the promise around smart mobility come to life. So with that said, I'm now very pleased to hand over to you, Anders, so you can tell us a little bit more how we actually prove that, connectivity isn't really a black box.
Unboxing the black box, is that what you're asking?
Unboxing the black box, absolutely.
We'll see. Okay, so in the digital economy, the data is really a key ingredient, but so is insights and actions. And remember this, so you can call this a formula for success, Collect data, draw insights, take action. Don't forget the action. You can even think about replacing this sum with a product, the data times insight times action becomes value. Because if any of these are missing, you don't have the data, or you don't have draw insight, or you don't take action. Don't expect another outcome, okay? Very basic. So what does it look like data from Telenor IoT perspective? Well, we process 500 billion real-time events every single year. That's a huge number, lots of zeros. The data comes from across over 500 mobile networks across the globe, and of course is sampled through our 25 million subscribers. These data is fed into over 5,000 AI machine learning models. And let's stay a little bit here. What are they doing? Well, they are sampling control plane protocols, communication from the device subscribers and across the networks. This is fed into 5,000 models that learns what is going on a normal basis. Okay? So the anomaly detection here is rather to detect an outlier from what we learned is normal. So now, how do you operate 5,000 AI things, models, whatever? It's a lot of maintenance? Not really. We design them so they are self-trained, auto-calibrated. So when you as a customer are launching a new product on a new market, the models will adapt your customer model automatically. Or you launch a new product with a new characteristics behavior, we will learn that too within a very short time. Or we launch a new network somewhere in the world, in a country where there's already existing like 3 or 4 operators. And one more will cause a shift of the workload going from the existing networks to the new. That is also a customer adjusted for automatically. And lastly, 2G, 3G, sunsets are coming or already ongoing, which will impact sort of the behavioral patterns today we see. So when that goes down, the models will adapt very intelligently. So what is output of this? 5,000 models. Over a year, there's around 1,000 AI-triggered anomalies. So what do we mean by this? These are the ones that the AI models are outputting and has been curated by human experts and saying, these are something we need to follow up. So they are escalated into our case management system and follow these standard business processes to drive quality in outcomes. But don't worry, it's around only 10% of those that are so serious that they actually are not transient or they're something that actually requires action. And those are the ones that we communicate. And our customer gets around twice of these a week. And then we assure them that we are working on it, we know how to contact, and they are working on it to solve it, etc., and so on. So, how does this look like? Well, our service operations center, the one that operates 24/7, 365 days a week, IoT experts looking at data, looking at screens on the walls here, you know, the network operating center, use flight control tower thing, okay? They have 2 counters. One of this number of alarms that are not yet acknowledged, and the other one of the numbers that are acknowledged. This requires them to do something. So this slide describes sort of what the whole data collection is actually about and what we do about it. So if you start on the left side, there's a car with a SIM card in it, and it wants to connect. So when a car comes in to a new country, it will scan the air and through the modem and see 4 or 5 networks. You need to pick one of them to attach. The attachment allows them to do SMS or voice over the circuit switch, the old style. And that request comes to the local operator, who in turn call us at the core, at the center of because it's our SIM cards in this. So we need to approve that they attach to this network. And if the network they want to attach to is not in the roaming profile, we will deny. Or it's not in the roaming steering platform, so it's not the preferred network. We might send a roaming not allowed back, which is an error code requiring the car to switch to another network. That's a new arrow down to the local network asking us, and we approve it, okay? That's not all. The second step is to create a data session now, because all we have now is just attached to the network. We need a data pipeline to send bytes and packages. That is another request. And if it's successful, we'll set up a end-to-end encrypted line from the mobile world into the over the internet to the customer's data center or cloud through VPN tunnels, etc. The data we actually collect is not the sensor data, it's not the telemetry, it's not the driver personal information, nothing like that. It's just the metadata about someone, subscriber or SIM card wants to attach. Set up data session. We get the time point, the network, the subscriber ID, the type of request, and the outcome, if it's an error or not, and what kind of error. That is the control plane, which we stream through a secure line up to the AWS cloud, and that's where we have the anomaly models. And out of them comes the score. If the score is high enough, we say it's anomaly, and that's where the service operation starts to work on it. So, long story, what could you expect of this? Does it actually have any kind of accuracy to account for? Well, of all the disturbances and incidents we see over the course of a year, 99% of them are initially detected by these AI models. So extremely accurate in that sense. And we have had this into production for 5 years now, so we've done this very long. And since we deployed this back in 2020 or something, we've seen the NPS scores going up every year. I'm not saying there's a causality between these, but there is a correlation that we have improved our customer satisfaction a lot since this. What did we do before we had these AI models? We still had the data. We still had real-time dashboards with drillable capability. We can go down to a country, we can see which customers were there, who had which behavioral pattern, and so on. But if you look at it, it took them 2-3 minutes to look at a slice of an aggregation data over a course of 5 minutes or something. That added up, and the scale of our business is huge. So how do you do that? Well, we did some back translation, because this was how we worked before the AI models were introduced. And now, what the AI models are actually doing is the same amount of work that the IoT experts were doing before, and this requires us to have 3,000 people if we not would have the AI models. So now you can think a little bit. So what would a competitor need to have in order to reach the same level of high-quality monitoring? Either 3,000 people. No, sorry, IoT experts, actually. Or they need to have our AI capabilities. So what we've seen is the customers are very happy with this solution. And there is a few customers that have come to us afterwards. When we tell them the story, afterwards, they've joined us and become a customer, they've grown and so on. And they have multiple providers. They tell us that we are super good at this, even so that they use our disturbance notification to tell their other vendors what they need to do about their networks, okay? So, yeah, many times it's not the networks themselves that detect this, it's we that do that. Okay. So, that concludes the first part of the AI-based monitoring, and I'll give you over to Marie to do some introduction for the next.
Yes, thank you so much, Anders. If you have more questions to the AI-based monitoring and how we do that to secure uptime and reliability, we will be around here afterwards, so please come and ask all your tricky questions to Anders, because this really makes a difference. And as we said when I started, it's about things working, and being proactive and finding things quick is super, super critical to keep customers happy. But we don't think it's only about that going forward. We know that the world is getting more and more complex, and we will now talk about another topic where we can use data and AI in a new way that we have not really done in the industry before, and it's about what we call service orchestration. And I will not go through this busy picture with you, but it's somehow an illustration of what we picture the world to look like for example, a car OEM in a couple of years, or maybe some are even there today. You work with several connectivity options. You have several connectivity partners. You might use several connectivity technologies. You have several platforms and partners that are integrated to each other. You have a lot of different use cases that require connectivity to be used maybe in different ways. Some things are time critical, some things are not time critical, some use cases need a lot of bandwidth and some others not. So it's a lot of different requirements to consider. And how to manage and work with data in this setup, well, that is something that we would like to talk a little bit about here. And to simplify things a little bit, we made this picture. We know the world might be somewhere in between, but if we look backwards into the past, we very much saw that customers of ours, they selected connectivity partners very much hardware generation driven. So there was a new hardware to be built for a certain generation of cars, and then you went outsourcing and you find partners to work with. And the goal was really cost optimization. And I think looking forward, what is very, very interesting to think about, what about like with software and connectivity, it's really becoming a separate layer on top of several car models and generations of cars. And instead of really selecting your connectivity options based on the hardware, what about doing it based on use case? And maybe not only optimized based on cost, but also like performance and customer satisfaction. Will this be possible? What do you think, Anders?
Well, we've been thinking a little bit about this, and we'll present our view on how to approach this. So, let's see. So if we start with sort of the traditional way of looking at the connectivity operating model, you have the car with different use cases of connectivity. Used to have the OTA, the telemetry, the music, the remote management, navigation, and so on. What usually happens is that we have sort of one unified connectivity demand profile, the one way of sourcing connectivity for all of these cases. Then you go to take the local or roaming network providers, and you deploy yours through a SIM management. You give the car through the TCU, the telecommunication unit, a profile that will work for this, okay? However, as we discussed, this has changed now. the variety of use cases for connectivity now is exploding. There's so much more. We have now vehicle to home, vehicle to grid for EV cars. You have data offloading. You want to do SOTA updates, which is software over-the-air updates. Can be massive. It's code that needs to be deployed. AD and ADAS. You have streaming video and Wi-Fi hotspot, etc. and so on. And even the CITS, I don't know if you know what that is, but in the future there will be communication between cars between traffic lights, cars and roadworks, cars and e-bikes, okay? So there will be a synergy like near surface or nearby communication to alert, inform. So now we have multiple connectivity demand profiles that all look a little bit different. And at similar time, we have done different connectivity type providers. So we have the mobile network operators, we have the private 5G, satellite and Wi-Fi. All of this is what our customers are talking about. This is what they want. And they want to match and so on. So what if the connectivity providers now, if you look at, they can't provide the same quality everywhere. So in some countries there will be some latency, some throughput expectations, etc. And even within a country, there are areas in the country that will work better or worse. So also are the network functionality that you might require for different use cases. Some might work when the car is powered off, some must work when it's powered on, etc. And of course, the commercials are different. There might be bundles, their pricing and tiering, or whatever it can be. But this is what you want to select your connectivity based on, normally. So if we introduce this concept of the network area capability profile, and every provider at the bottom exposes this, then through data, AI analytics, there's now a space for someone called the connectivity orchestrator that once the area capability, the network area capability profiles are published in the network library, the car can send the use case through the connectivity demand profile to an advisor, scan the library, see what are the best options, and send the recommendation back to the TCU. So maybe we shouldn't switch profiles all over for this, but what we've seen is an increased discussion on multiple enabled profiles. So you have one or two for satellite, maybe, and you have one or two for local in the network, and one for roaming. So you can switch between this. We'll see. But this is a way we can optimize based on use case. So is this the future? Yes, but how far are we from reaching this? Well, I'm arguing that there's only two parts that are missing. And the white box in the middle is the unified data model. That is what's missing. We, as an industry, the connectivity providers and the OEMs or IoT actors out there, we just need to agree on this language. It's a data model. How do we describe this? If we can do that, there's an open space now to claim for someone to become the connectivity orchestrator. And of course, it can be an OEM in this case. They can do this, or they can go together, several OEMs, and collaborate on this, or they can be a complete third party that takes this space. Customers have asked us if we can take this role, and yes, of course, but there's a trust thing here, Are we recommending our own networks or the best network for you? It's a trust thing. Then it will work. But yeah, it's very close. So that's what I'm saying. It's not that far from the future. Okay. So some concluding remarks now. The OEM's reality now is there's a huge diversification of the connectivity types you can pick and choose from. The Wi-Fi, the satellite, the MNOs, and so on. But also, the use cases are also diversified. So our commitment is that support these two things, the connectivity orchestration platform plus on our footprint that we offer on the market. We will, in the future, be able to support this network area capability profile. So you can ask us, what are the best? Okay? So my final thing here is the call to action. So if you're in automotive industry representative or, want to be the orchestrator, then form this forum, industry-wide consortia or something to form this unified data model. If that happens, it's just an engineering small thing to build the APIs. and build an advisor. It's very simple. We just need to agree on the common language. Okay? And then we will have this fantastic ecosystem of connectivity, the right use case. Okay? So, Marie, do you have any final words?
Some final words for me, and just to pick up what you just talked about, I've also been on the OEM side, so seeing the connectivity business from that perspective too. And I know today how different the access to data can be in between different partners. To find a unified way of managing this, we believe could really come with very, very new opportunities for our industry. And as I said, also from an IoT Drive perspective, which is the offer that we now are launching, this is a key part because we believe a lot in what we say is the life cycle management, the operational phase. It's the hardest sell, I'm sorry for that, because it's very intangible. But when you start experiencing it, you know, everyone appreciates it because that's really where it starts when the cars are out there on the road. But we see an increasing complexity, we see increasing costs, and we see higher quality demands. And as we said, we will try to do everything that we can to support the industry on this journey to make things easier and smoother. And if you want to talk to us more about data, more about what we do, we will be around. And you can contact us here also by scanning the QR code.
Or drop by our booth in Hall B too.
Yeah. Good, Anders.
Yes.
But to end this presentation, we will show you a short movie. It's like 1 minute that somehow summarizes what we stand for and what IoT Drive is very much about. So please enjoy. Okay.
Telenor IoT Drive, where true connectivity sets the standard for a seamless in-vehicle experience. With us, automakers can bring their vision of a truly software-defined car to life. Drawing on our vast experience and expertise, we engineer intelligent connectivity services that make every drive perfect everywhere. Our solutions are reliable and scalable by design, ensuring everything from international compliance to tailored local experiences. Built for automakers, we enable secure monitoring, over-the-air updates, and performance insights that keep quality high, uptime strong, and users satisfied. Our technology gives every driver, passenger, and vehicle exactly what they need, from essential services to moments of pure enjoyment, all through seamless, glitch-free integration. Enjoy the ride with Telenor IoT Drive and experience pure flow.
Thank you so much for listening.
Thank you.
Thank you.